this video, we will talk about a topic called curves. Curves are provided when you have two survey lines meeting at an intersection and you need to change the direction. For suppose you are traveling on a highway. When you are traveling on a highway or in a railway, you never come across a road which is straight. You always have the change in direction of those lines. So when you have change in direction, you cannot have a sharp change in direction. So we need to provide a curve in which the change in direction is smooth and so that accidents can be avoided. So the curve is defined as an arc with a definite radius provided at intersection of survey lines, right, to negotiate the change in direction. So this is the definition of the curve. So how is it? Now we got two lines here. You take a look at this diagram. Okay. Now you have a survey line coming, which is a highway, railway, you can say, and you have another line here. And if I join them together, they are intersecting in point I. So I cannot have a vehicle coming here and have a sharp curve change in direction. So in order to do that, we will provide a smooth curve for the change in order to negotiate the change in direction. So when this change in direction is there, wherever it is there, we will provide a curve. The curve type will depend upon the intersection angle. We will talk about more this intersection angle or definitely reflection angle. Both of them similar. Right? So there are two classifications in curves. One is horizontal curve and second is vertical curve. Horizontal curve is when you look from top, right, you can see the curve. When you cut the intersection of the curve, then you can see the curve. Either it can be a summit curve or a sag curve. Summit curve looks like this when you cut the intersection, and sag curve will look something like this, right? So these are the vertical curves. Whereas if you take a look of the horizontal curves, there are mainly 5 types of curves: simple circular curve, compound curve, reverse curve, transition curve, and combined curve. When the arc in the curve is constant throughout the curve, then that is termed as a simple circular curve. So from the point of tangency to the point, from the point of curve to the point of tangency, you will have the same radius. If that is so, then that is termed as a simple circular curve. From the point of tangency to the mid-ordinate, if you have one radius, and from the mid-ordinate to the point of tangency, if you have 2 or more, I got 2 radius here. Sometimes we can have 3 radius also, radii also. So then that is termed as a compound curve when you have more than 1 radius. Reverse curve is you have 2 curves, but the center points are in opposite direction, whereas here it lies in the same line. For the reverse curve, the curve for the radius for this and radius for the second curve are opposite to each other. So that is termed as a reverse curve. You can see denoted with the arrow as the direction of the highway or the railway. So I repeat, curve is provided when there is a change in the survey line direction. There are 2 classifications: horizontal curve and vertical curve. Vertical line curves are summit curve and sag curve. Horizontal curves are simple circular curve, compound curve, reverse curve, transition curve, and compound curve. I have drawn 3 types of curves: simple circular curve, compound curve, and reverse curve. So the transition curve is majority provided in highways. So you cannot have an immediate radius to a highway when there is change in the direction. So I have provided a circular curve from the point of curve to the point of tangency. Normally it is not done in that way. What we do is we are introducing a direct R, which is a constant value, right? So whereas if we introduce a parabola up to certain point, from this to this parabola, from here to here circular curve, from here to here circular curve, from here to here parabola. Parabola, what is the specialty of parabola is you can start from 0 radius, then increase the radius and reach up to the circular curve. Then circular curve radius will be constant and this radius will be gradually become 0 and joins to the highway. So when the speed of the vehicle is high or expressway, this transition curves is usually in all of the highways rather than the street roads and rural roads. Transition curve is provided. So what is transition curve? In transition curve, you get a part of the curve as parabola and part of curve as circular curve, right? And combined curve, when you combine 2 or 3 curves, then that is called as a combined curve. Okay. So in our syllabus, we will discuss more about simple circular curve. So this is how the simple circular curve is there. Now I am coming from A and I need to move to B, so there is change in direction. So I have provided a constant radius of R. This is constant. I have provided a radius here, a curve there, and this is called as radii or radius. Okay. Now the starting point of the curve is called as point of curve. The starting point of curve is called as point of curve. If I am coming from B to A, then this will become point of curve. So as I am talking from here to here, starting point of curve is called as point of curve. The ending point is called as point of tangency, and the middle I got a curve. Point of curve, which is T1, point of tangency as T2. When I join them together, I get a point of intersection which is denoted by I. And there is a change in this is one line and this is one line. This line is deflected and that is termed as a deflection angle delta. And then there is an angle here. This angle is termed as angle of intersection. Theta can be calculated as 180 degrees minus delta. Now, from the point of curve to the point of intersection, when you are traveling from A to B, this is called as tangent length. T1I is called as tangent length and IT2 is also a tangent length. For a simple circular curve, T1I and IT2 are same, the lengths are same. And if I calculate this length, what is this length is, if I join point of curve and if I join point of tangency, then this is called as a chord or long chord. This is called as a long chord. T1, D, T2. And if you happen to drop a perpendicular to the center point or the midpoint of the arc, then this is termed as a mid-ordinate. Mid-ordinate. And this is called as a versal sign of curve or mid-ordinate. This is called as and this is called as apex distance. The CI is called as apex distance. Fine. These are the terms which you need to remember. Majority you need to remember tangent length, long chord length, and length of curve. So when I am talking about chainages, you need to remember very carefully. If the chainage of point of curve is point of curve, chainage is 105.600 kilometers, right? And if I know the length of curve as 3 kilometers, then the point of tangency will become point of tangency. So what it says is, from up to here the change is how much? 105.6 kilometers. I need to calculate the point of tangency change. And if I add the length of curve 3 kilometers. I will get point of time. So this will become 3,108.600 kilometers. Fine. Now, if I know the length of tangent or tangent length as 10 kilometers, and if I add the 10 kilometers to point of curve, if I add length of tangent 10 kilometers to point of curve, now where I reach, I'll reach point of intersection. So this is how you need to now play around with the changes values. So if you have a point of curve and if you add the long chord length, if you add long chord length, it doesn't mean that you will reach the point of tangency. Long chord length is not used to calculate the change calculations. It is always used to length of curve is always used to calculate the change of point of tangency. Fine. Now we got the equations in order to calculate the values of this depending upon this main factor, that is deflection angle. And there is a relationship between the degree of curve, right, and the radius of curve. The center angle is the angle subtended by the curve in the center. Right? The curve in the center is called as center angle. Now, degree of curve is always written, if you happen to notice, in any highway curve or railway curve. Normally, highway curves are not provided with the curve details, but railways you will have a small board with all the details of the curve length and everything. So, first, what we discuss is a degree of curve. So, if you happen to have a PQ of curve 30 meters, imagine an arc of PQ 30 meters, right? And if I join them, I'll get some angle D. This D is nothing but the degree of curve. So, degree of curve in practice is designed, or it is designated as the central angle of the curve that is subtended by 30 meters arc length. 30 meters arc length, how much the angle subtends, that is called as a degree of curve. For example, if arc length is too short, if radius is too short, very small, right, that designates something. If radius is very large, you get more. So the degree of curve talks about how much sharpness of the curve it is. Now if I take a look here, the radius is very small and the radius is increasing, right? For every radius, the sharpness of the curve is increasing. This was first adopted by the Great Britain, later it was also used by US, Canada and in India also. And if you happen to calculate the relationship between the degree of curve and radius, I can calculate this length as 2 pi r into x by 360. What is x? X is nothing but d. So if I have this equation 2 pi r into x by over d, this equation is the part of coordinate which you have learned in mathematics, which shall be equal to 30 meters. So what is this x? The angle subtended by the r. So this is x. Our x is our d, and 2 here will become 190. And if you happen to simplify this, you get as radius equals to 1719 by d, where d is the degree of curve in degrees and r will be meters. In some of the curves, they designate 20 meters arc length rather than 30 meters. You can also have 20 meters arc. So, 30 and 20 meters predominantly because 30 meters metric chain is there, 20 meters metric chain is also there. And based upon the comfortability, they will the highways and the railways will follow. Okay. So, if 20 meters arc length is used, this comes to 1146 by 2. So, you need to remember the evaluation or this thing. Then you can calculate the radius of the relationship between the radius of curve and degree of curve. What is meant by length of curve? Length of curve is nothing but T1 C T2, which is given by pi r delta by 1 area. What is delta? Delta is nothing but what? Deflection angle. Then you have tangent length, right? What is tangent length? It is I T1 or I T2. These both are tangent length and these both are equal. This is given by R tan delta by 2. What is long chord length? Long chord length is T1 D T2. From here to here it is called as long chord length, which is given by 2R sin delta by 2. What is apex distance? This is called as apex distance, which is given by R secant delta by 2 minus 1. And mid ordinate is called as vertical of curve, which is given by R into 1 minus cos delta by 2. Now, we will do one problem. We will be given with a certain data and you need to calculate the length of curve, tangent length, long chord length, apex distance and mid ordinate. So, there is no other option. You need to remember all these formulas. We will discuss about one problem here. A circular curve has a 200 meters radius and 65 degrees deflection angle. Calculate the deflection of curve. Elements of curve, what are they? We have discussed. We have to calculate the degree of curve. We have to calculate length of curve. We have to calculate the tangent length. We have to calculate the long chord distance, long chord length. Then we have to calculate the apex distance. Then mid ordinate. So these 7 we need to calculate from the given data. Okay. So first is we write down the given data solution. Given data. Radius R equals to 200 meters and deflection angle. How will we denote deflection angle? We denote deflection angle with delta, that is 65 degrees. First we will calculate the degree of curve. Degree of curve. Taking, you have two things, that is 20 meters arc is there, 30 meters arc is there. So if you take 30 meters arc or 30 meters chord, you can take anything, chord or arc, then this is given by how much R equals to, we got 1719 by D. If I am not wrong, we have calculated this, right? 1719 by D. So, and if 20 meters chord is there, 20 meters chord is there, this will become double 1146 by D. These are the two things, right? Now, we know the radius, we can calculate the D. So, D is given by 1719 by radius is 200. Here, D is given by, if 20 meters arc is given, 1146 by 200. The degree of curve, if you take 30 meters chord length as definition, then this value will come 8.595. 8.595 degrees. So, now what does this say to you is, if you have a degree of 8.595 degrees, then you can subtend 30 meters arc. 8.5 for the given radius, 200 meters radius తీసుకొని, and if you have an angle of 8.595 degree, then you will get 20 meters square. Similarly, you please calculate for 20 meters square. This is for you. Okay. Calculate. Next, when you have degree of curve, you can calculate length of curve. Length of curve is given by how much? Pi r delta by 180. Pi r delta by 180. So pi r is 200, delta is 65 degrees by 180. If you happen to calculate this value, you will get length of curve as 226.89 meters. The third one, then we have tangent length. After tangent length, we will calculate length of long chord. We have long chord length of long chord. Then we have apex distance. Then we have mid-order. So tangent length is given by r tan theta by 2. This we have discussed. This is 2r sin delta by 2. This is r into secant delta 2 minus 1. This is r into 1 minus cos delta by 2. So r is 200 into tan 65 degrees by 2. This is 2 into 200 into sin 65 by 2. This is 200 into secant 65 by 2 minus 1. This is 200 into 1 minus cos 65 by 2. The tangent length you will get as 127.41. The length of long chord as 214.92 meters. Apex distance as 37.13 meters. And mid-order length as 31.32 meters. So these are the elements of the curve which we need to calculate, right? Fine. So when you have a curve, right, we need to mark that on ground. Whether it can be a simple curve, it can be a compound curve, transition curve. So you need to mark that on ground so that you can have a earthwork which is done based upon your curve alignment. So in order to plot them on straight line is very easy, right? You can have set up a clear line and you can set the next line and you can fix it. You can set as many interpretation points as you like, as far as your visibility is good. So when you have to change in the directions, so there are two kinds of methods in order to plot the curve on ground. One is linear method, second is angular method. In linear method, we will use either chain or tape. No angular instruments we will use. Whereas in second, in angular method, we will carry chain or tape along with the angular instruments. When the degree of curve is, or the radius is very small, okay, then we will use linear method. When the degree of curve is more or the radius of the curve is more, then we will go for angular method, even for the compound curve. Okay, we got 5 pillars in linear method. offsets from long chord. So we have a curve, I'll draw a curve. If you have a curve, then I've said T1, T2, and this I have said as D, and this I have designated as C, right? And this is called as a long chord. And but at every interval, if you take offsets, offset is nothing but a perpendicular, right? And if you know this distance, right, then that is called as offset from long chord. Similarly, you have a tangent here, right? So from tangent, if you take perpendicular, this will be here 0. Then if you know this as x value, x is changing, this is fixed, x is changing up to here. And if you know this y value, this is perpendicular. And if you can calculate these values, right, then you can up to here, and you get the ground, right? So that is called as perpendicular offsets from tangent. Radial offsets are from tangent is if you know this point and if you know the curve, this you know this x value, and you draw a curve, and these are called as radial offsets from the tangent. Successive bisection of arcs we will learn. Offsets from long chord produced, this both will be discussed in later parts. And in angular method, we got Rankine's method, that is, we will use only one theodolite. And second, we have two theodolite method. If we have two theodolites, we can also draw or set up or mark set the simple circle curve and trapeze method. So all these methods can be used in order to set up only simple circle curve. For the compound curve, there are different methods. For your simple system set, only setting of simple curve is all needed. We will discuss in detail about these methods in next video.